Okay, so here we're going to prove that if the limit as x approaches c of f of x equals 0 and the limit as x approaches c of f of x times g of x equals 1, then the limit as x approaches c of g of x doesn't exist. So how we're going to prove this is by assuming for contradiction that the limit as x approaches c of g of x actually does have a limit, and we're going to call that L. So using this, we're going to see with our assumptions to see that everything is also true with our assumptions. So quickly, since we know that the limit as x approaches c of f of x is 0 and it doesn't have anything to do with g of x, we don't really have to look at this. We just have to look at this part. So when we work through it, we can use a limit laws to see that we're going to have f of x times the limit as x approaches c of g of x, and that all has to equal 1. So we already know that this limit is going to be 0 just by our assumption, and then by our other assuming for contradiction that it's actually existing, it has to equal L, and that has to equal 1. Remember, L is a finite number. L does not equal infinity or negative infinity or a does not exist situation. It has to equal something finite like 1, 2, 3, 0, whatever the case is. So numbers like these can't possibly give you 1 because 0 times any types of these numbers is just 1. So since we assume that this existed, and we know that numbers like these with a finite limit existing cannot give you 1, therefore it must be the case that the limit as x approaches c of g of x does not exist for this reason right here. We've seen a contradiction, and the contradiction that we see here is that 0 times something is going to give you 0, but that must equal 1, which is just not the case. That just doesn't work that way. So there's our contradiction for this proof of showing that the limit as x approaches c does not exist with our assumptions that the limit as x approaches c of f of x is 0 and the limit as x approaches c of f of x times g of x is equal to 1.